Okay, let's continue. So, so we use linearization to obtain the variance of the regression estimator, right? So now, okay, let's write it again. So variance of the regression estimator is roughly equal to variance of the d bar, where d bar is the sample mean of the di, and di is the population residual of the regression model. And now, so that is 1 over n, 1 over n, 1 minus n over capital N, SD square, and SD square is essentially 1 over n minus 1 summation I equal to capital N di minus d bar u, and d bar u is 0 because the summation of the di is 0 because we have an intercept. So the property of the residual will satisfy this property. So that means 1 over n yi minus b0 minus b1 x bar xi square. And this guy is we call it sum of square error, right? Sum of square residual. So let's take a look at this more carefully. Sorry. So this SSE yi minus b0 minus b1 xi square. So that is to be 1 plus b1 square okay, and then b1, by the way, is xi minus x bar u square xi minus x bar u yi minus y by u, right? So you can actually see that they you can simplify to get something like that. So that basically means that you can write it as a r square, where r is the r square is r is the population correlation coefficient. Okay, so that's this formula. So now this r square, it should be less than or equal to 1. So that means this guy, regression, is 1 over n 1 minus n over n sd square, but sd square is sy square 1 minus r square, and so that is sy square. Sorry, the other way. sy square, right? So that means the overall, this is 1 minus n sy square, so that is the y bar. So that is an interesting result, because that basically means that the regression estimator is almost always has a smaller variance than the sample mean, which is a very attractive property of the regression estimation, right? And now for variance estimation, we have only to estimate this sd square. So we need to ask how to obtain this sd square. I mean, how to estimate this sd square. But this is 0, so that is square. The problem is we could so if we observe the di's, then we can use a small sd square to estimate it, right? The problem is that we don't know sample. So the problem is that we don't observe di, because this is unknown. So the idea is, okay, now let's estimate it. So and call it ei. Ei is yi minus p0 hat minus p1 hat. Okay, so that is the sample residual, and then apply to here. Okay, and notice that the bar ei bar sample is equal to 0 because of the property of the residual. So you don't have to worry about the second part, and so just you have only to so that is the ei, right? So you have only to use this formula for variance estimation.